All right, hello everyone. Welcome to week 6. We are going to be looking at percents today. You have to excuse my voice. I'm losing it. Combination of being kind of sick, cold, had a weekend where we spent a lot of time on the streets. So I'll be drinking some warm stuff to try to keep my voice going through this, but hope everyone did well in the midterm. And let's get into things. So all right, let me share my screen and we're going to be opening the PowerPoint and looking at percents. So again, definitely something practical that comes up in normal life. You don't have to look too hard to find a situation where you need to use percents. So the word percent comes from the Latin breakdown. Per means for every, and then cent, you think century. Cent refers to 100. So the word percent literally means for every 100. So that can kind of help you when you think, like, when you're saying, what percent is this? You're saying, of this item, how much do I have for every 100? So if you have, I mean, we'll get into it. We'll get into the numbers. So when you make a fraction, which is just a ratio, it comes from division, right? Like a fraction is a division problem. And so different fractions are sometimes hard to compare. And so the idea with the percent is, why not always take these ratios or fractions and divide by the same number, so we're always comparing them, right? So if I say that I have 2/3 of this and 3/4 of that, it might be hard to compare. But if I say I have 67 out of 100 of this and 75 out of 100 of that, I mean, you can compare them because they're both out of 100. So that's the idea with percents, is really to make it so we can compare things because everything is out of 100. And so since we are using a decimal system, let's pick something that's a multiple of 10. And since money is divided into hundreds, right? Money is divided where the pennies, 100 pennies, 100 cents makes up a dollar. A lot of the percents we'll deal with will have to do with money. So let's just make it so that this system, this percent system, will compare everything to 100. So by comparing to the same number, we're all on the same playing field. And so this makes comparisons easier. It means that we can solve as a proportion. It means that we can solve as a fraction. It means we can turn things into decimals. And then we can just round things, use hundreds to estimate answers. All of these are options. And so the way we'll approach things today is, the first thing I'll do is I'll break down what I mean with these 4 options. I'll give you an example what they look like. And then after that, I'm just going to, in each situation, pick which option makes the most sense. I might be scrolling back to my opening examples, but I'm just going to show you where you have these. Maybe there's just one method that you're always going to want to use. But for me, I'm just going to pick what's easiest. I think I'll probably use this third method, using decimals, as often as I can. I find that easiest, but it's just depending on the situation is going to kind of dictate to you what method makes sense. So first off, if you're going to convert to a percent, if you're going from a fraction, an easy way to approach it. So like the opening thing I said, 2/3, 3/4. Let's take 3/4. You're going to take these steps. You'll multiply by 100. You'll reduce to a decimal. You'll round to the nearest tenth, and then you'll place the percentage point. There's a reason why, like, we worked on rounding already. The idea is, I'm hoping that you can handle all this stuff at this point. You might want to, if you're taking notes, which I don't obligate you to take notes for this class. It might be helpful though to have a piece of paper and jot things down. So then at the end of the lesson, when I'm having you work problems, you kind of have your notes of how to do things in front of you. So if you're going from fraction to percent, you want to take your fraction and multiply by 100. So let's use 3/4 as our example. You take 3/4, you multiply it by 100. What does that give you? It gives you 300 over 4. And then what you're going to do, you're going to reduce to a decimal, which 300 over 4 becomes 75. In this case, it's like essentially 75.0. There's not really a decimal, but it could have been 0.75, could have been 7.5, could be 0.235, whatever. It could be anything. And then what we do is we would round the nearest tenth, which in this case is not necessary. This round to the nearest tenth step is necessary if you get, imagine if what we did ended up with 75.2345678, right? And it's going on forever. The idea is round to the 10th. And then once you've made it so that your decimal points are reasonable by rounding to the 10th, you just place a percentage at the end of it. And there you go. So what about if it's in a decimal and you're converting to a percent? So what you're going to do is you're going to take whatever you have and you're just going to multiply by 100, which is essentially the same as moving this little decimal place 2 spaces to the right. So 0.75 times 100, just take this decimal, move it over, so you're at 7.5, move it again, so you're at 75.0. We don't need to write the decimal at the end if it's just 75. Nobody says 75 decimal point. So you can just, but really what's going on here is it might as well say this, 75 point. You just don't need to put it there because we understand what's going on. So you move it over 2 places and then lastly place the percent on it. So that's how we would go from a decimal to a percent. From a percent to a fraction. So if it's 75%, you just get rid of the percent, so it's just 75. You then put the whole thing over 100. So it's 75 over 100, and then you reduce 75 over 100, you'll divide by 25. So 75 divided by 25 gives you 3. 100 divided by 25 gives you 4. So you just reduce. And then converting backwards from a percent to a decimal, you remove the decimal point. So, you remove the percentage sign. So 75%, get rid of the percent. So you're just saying 75. And then you divide by 100. So 75 over 100, which if you plug that in a calculator, it'll say 0.75. So the other thing you could do if you're taking a percent and converting it to a decimal is just same as last time, how there was an invisible decimal place right here. Well, if you're trying to turn it from percent to a decimal, just slide this over. So it's 7.5, slide it over, so it's 0.75. So you'll just see me when I'm moving fast, just slide the decimal place over 2 points. Look at some examples. From a decimal to a percent, if it's 0.89 and we say what percentage is that? You just multiply it by 100 and you get 89. So you'll say 89%. So if you say like, if you say like, I have a pound of this. And then I say of that pound, when I cooked it, I had 0.89 pounds. And so you say, how much did I keep? 0.89 times 100, 89%. So I kept 89% of my object. If you're going from a percent turning to a fraction, if it's 23%, that's just 23 over 100. And if you could reduce it, you would. So what's 25% in terms of a fraction? Well, that would be 25 over 100. And if you do that, you would have 25 over 100. So it's 25%. And then you're going to say 25 over 100. And then you're going to go, okay, 25 over 100. Divide by 25 and it's 1. Divide by 25 and it's 4. So just reduce the fraction. So 25% is the fraction 1/4. And then lastly, on this slide, converting from a percent to a decimal. If I have 27%, just remove the percent, slide it over. That's 0.27. Okay, so this is the page to try to make it feel simple. And so I might slide back to this page once we've worked on a lot of problems, if I feel it's necessary to remind you of this page, but that's where it feels simple. So now let's think about how we're going to approach these. So with the word problems, there's a bunch of different approaches. And so what I'm going to do is I'm going to pick one problem and demonstrate 4 approaches to it. So here's the problem. 59% of all organ donations are kidneys. If there are 28,291 organ donations, how many were kidneys? So basically, we're breaking it down like this. Okay, so we're saying that 59% are kidneys. And there are 28,291 organs. And so how many kidneys? So you see, Our percent is 59%. Our total is 28291. How many are kidneys? So of 28291, if you have 59% of that, what amount will you get? So the first thing we have here is to make it a proportion. Make it 59 over 100 equals X over 28291. Let me actually stop sharing. Let me show you how you'd write this. So it's like, okay, so a percentage is out of 100. So what you're going to say is 59 out of 100 equals, and the percentage is how many kidneys you have out of total organs. So your proportion will say 59 out of 100. Well, we had X kidneys out of a total of 28291. And so it's a proportion. So to solve it, we do X grande. And so we have 100X equals, we do 59 times 28291, which equals 1669. Oh no, I'm sorry. Let me actually break this down into the steps. So I'll write it out like this: 59 times 28291. Let me pull up my calculator right here. I'm not about to do this in my head. That would take me a while. So we do 59 times 28291, and we get 100X equals 1669169. We divide by 100, and we get X equals, this will be 16691.69. Okay, so if we're going to round it to, it doesn't say what we need to round it, but we're trying to figure out how many organs. So if we round up, we're going to say about 16692. So our answer is 16692. So that's how you can take it, set it up as a percent, knowing you can, set it up as a percent. Set up the percent as a proportion, knowing that all percent is however many things you got, it's out of 100. All right, so back to share. So that's how we would do it, setting up as a proportion. So keep that in mind as an optional method. Another method is to make things into a fraction. So if we have, so I'm going to erase this. And you'll notice this will force us to do basically the same math that we did with the proportion. It just sets it up slightly different. So the idea is this: we have 59%. So 59 out of 100. And we're trying to figure out if there are 28291 total organs, then 59 out of 100 are going to give us how many kidneys, and you just multiply across. And so when you do this, you'll just do 59 times 28291, figure out what that is, and then divide by 100. And when you do that, you get 16691.69, same as before. And it sets up the same exact math as before, that you're doing 59 times 28291, you're dividing by 100. It's just, this is a different approach where you just set up, if it's like 59% of 28,291. So instead of thinking 59% of it, that's 59 over 100 times it. So whatever you want to do, if it's like, if you're trying to figure out, I made $100,000 and I'm going to get taxed 9% of that. Just do 9 over 100 times 100,000. Boom, you find out how much you get taxed. My bill was $82 and I should tip 20% of that. Do 20 over 100 times whatever your bill was, right? So whatever your percent is, make it over 100, then multiply it by your object, and boom, now you have the percent. One of the 4 ways of doing percent. Okay. Number 3 is solve as a decimal. I think this is the easiest way to do percent. So in the same way that last time I said, if you want a percent of an item, take however many of that item you have and multiply it by the percent that you want over 100, right? So if you want 59% of 28,291, last slide we did 28291 times 59 over 100. Well, here what we're going to do is just as straightforward, but instead of taking the percent and turning it into 59 over 100, you just turn it into a decimal. And 59 out of 100 is the same as saying 0.59 out of one whole thing. So to again, on the early slide of the simple breakdown of making percents, 59% is the same as 0.59. You just remove percent, slide the decimal over 2 places. So 59% is 0.59. 9% would be 0.09 because 9%, and if it's 9%, then you're going to remove the percent. You're going to take 9. The decimal place is basically here. So move it over 1, move it over 2. So 0.09 is the same as 9%. All right, so I'll be using that a bit as we go through. But I think what I'm showing you right now is the easiest way to do this. If I'm trying to figure out 59% of 28291, just do 0.59 times 28291. This is literally it. 16691.69. Same answer we got on all the other ones. Okay, so that's the way most of these problems, if I can, I'm just going to do that. So whatever you want to figure out what's 20% of my bill. You're just going to take 0.2 times your bill, right? You want to tip them real good. You want to tip them 30%. 0.3 times whatever your bill is, right? That's simple. I made $72,506.30. And I'm going to get taxed, I don't know, 13% of that. Take whatever it is that you made times 0.13, and boom, that's what your taxes are going to be. So that's the easiest way to take if you have an amount and you're saying, I need a certain percent of that. Multiply by the decimal. So the other methods are cool, but I'm going to use that whenever I can because that's the easiest to me. It's real straightforward. Then lastly, this method, which I might do this if I'm like running a quick estimate in my head of something. But if I'm going to bother writing it down and calculating it, I'm probably not going to use this method because it's not as exact. But the idea is what you're going to do is you're going to figure out how many hundreds you have of something and multiply that by the percent. So basically what I want to point out is that if it says, let's because if I want 5% of 100, what is 5% of 100? Well, 5% is how many out of 100. So 5% of 100 is just 5, right? Because it's let me see if I can break down why this method is worth anything. So the idea is, right, if you're saying 5%, that just means 5 out of 100, right? 5% is 5 out of 100. So if I'm saying what is 5% of 100, it's going to be 5. But the idea here is you say, how many hundreds am I talking about? Well, just 1. So if I want 5% of 100, I'm going to do 5 times 1 because that's how many hundreds I have is 1, and it's 5. So then what about what's 7% of 200? Well, how many hundreds do I have? I have 2 of them. So the idea here is just 7 times 2, and so it's 14. So 7% of 200 is 14. The idea with this method, because it works that way, is to just always round to 100. So if I'm going to say, what's 5% of 102? So this, I might do something like this in my head if I'm like trying to tip on a bill. I'm okay if I'm off by a little bit. So like if for whatever reason I needed to come up with 5% of 102, in your head, what you could do is just go, okay, well, let's just do 5 times and round that to the nearest 100, which 102 is just 100. So it'd be 5. So I'm going to say that 5% of 102, if I'm just rounding, I'm not perfect, is 5. So if I'm going to say what's 59% of 28291, well, let's round this to the nearest 100, which would be 2 8300. So how many hundreds do I have? I have 283 hundreds. So I'm just going to do 59 times 283. And 59 times 283 gives me 16,697, which is close to what we were getting on the other ones. On the other ones, we kept getting 16,691.69. So see, we're very close. So this could be something you could run quick if it's okay to be a little off, you don't need it exact, this would be an option. And again, we don't really care about like the number crunching aspect of this. We care about the practical use. And if you need to find a percent of something, maybe that's an easy way to do it. Okay. And then so that's how we could solve this using 100. All right. So just an idea of how we'll use percents. We'll use it for taxes, for discounts, for comparisons, to calculate interest, and to calculate the increase and decrease percent of change. I'll run through a couple of examples of these, and then the way that today will go, I'll run through examples of these. You'll have them there. You can scroll back and look at them if you need to, and then you're going to work on like 20 something questions out of the book, which you'll just pull the online PDF if you don't have a hard copy. And I'll have you work on those examples, try them, and then you obviously always have the answers in that book. But then what I'll do is I'll have me going through the 24, and that's how we'll structure this. So taxes. The sales tax is 5% on a $400 purchase. What is the tax and what is the actual cost? So for this, we're just 5% is what decimal. So move the decimal place over. I'm just going to go 5% of a $400 purchase. And what we want to find is what is the tax and the actual cost. And so you're just going to go 5% of a $400 purchase. So 5, remove the percent and take, there's a decimal place in front and move it over 1, 2. So it's 0.05 is my decimal. I'm going to do that for as many of these as I can. Times 400. And that comes out to just 0.05 times 400 equals 20. So the tax is 20 and the total cost, it's a $400 thing and you got to pay tax. So 400 plus 20 is 420 is what it actually costs. Okay, I hope that's simple enough. Okay, what about we have 20% off of a guitar that's $180. What's the discount and what is the actual cost? So same thing. I'm not even going to break this down on the board. I think you can see that 20%. So what I want you to picture is that we get rid of the percent and the decimals at the end of whatever the number is. Move the decimal over 1. So from here, move it over 1, 2, and it goes here. So 0.20 or just 0.2 is how you turn the percent into a decimal. And the object is 180. So 0.2 times 180, which equals 36. So the answer is 36 is the discount. And then what's the actual cost? So take the object, which is 180, minus the discount, which is 36. So the actual cost will be 144. So you see how this type of calculation, this is not just some idea, cloud in the sky thing. It's really practical. You'll deal with this all the time. Comparisons, we're talking about part of the group. So this is one where not a coffee, so I might get in trouble now. So 65% of the youth are female, and there's 45 in the youth group. How many of them are female? Now, this is one where I think it's actually helpful to think about a proportion. So let me stop sharing. Let's break this down right here. So 65% of them are female. So we have 65% female. And there are, what was it? There are 45 in the youth group. So 65% female and 45 total. So then how many female? So the idea is we have 65 out of 100 are female. So then X out of 45 total, how many will be? So it's 65 out of 100 are female. So if the total is 45 instead of 100, then how many females will we have there? X grande. So 100x equals 65 times 45. And so we'll figure that out, and then we'll divide by 100. And so we'll get 65 times 45 divided by 100. And that comes out to 29.25. And so you obviously can't have a quarter of a person. So we would end up, that's another thing when you're doing calculations. Your numbers aren't always neat and clean. So think about if you do a calculation and you're saying, how many people do we have here? And your number comes out to 29.25. You can't have a 0.25 of a person. So since it's only in whole amount values, if it comes out to 29.25, then you would round it to I have 29 people. But you just got to think about the situation. What if you're trying to come up with how many plates you need to buy, or how many items you need to buy to feed everybody, and you get 29.25 of that item? Well, if that's to feed everyone, even though 0.25 rounds down to 29, just get 30. So you have more than enough, because it looks like you'd be a little short. So that's the idea when you're talking about rounding with real things. But if in this case, if it comes out, if you say, well, 65% of the 45 people are female, and it comes out to this, then obviously the 65%, it was rounded a little bit, and you would just take 29.25, go with 29. All right, so let's go back to go. All right. Interest is the cost for borrowing money or an item. And basically what interest is the idea is it's what you pay for not having the cash up front. And the simple interest formula is just I equals P times R times T. I is the total interest you're going to have to pay. P is the principal, which is the amount that you borrowed at the beginning. R is the rate. And so that'll be your percentage, right? So the housing market went crazy when rates were dropping below 3% a couple of summers ago, and now they're up to 5, 6, 7%, depending where you're at and what you're buying. But so rate, the percentage, and then T, time, is how long it's going to be where you have that money borrowed. So Jim invests 3% or $300 in something that gives him 5% for 3 years. So let me write. Well, I don't need to write up here. I think I can just remember the formula is I equals P R T. P times R times T. So P is the principal. So which of these is telling you how much he borrowed or how much he invested? How much is earning the interest? The principal amounts 300. So in place of P, you'll put 300 there. It's just a formula where you just plug stuff in. R is the rate. What's the rate? It's 5%. When you punch in a rate for a formula, you need to take your percent and turn it into a decimal. So it's $300 is earning 0.05 as a decimal form, which is the same as 5%. And then T is time. It's happening for 3 years. So you put 3. And when you plug all these in, then your interest comes out to 45. So what's going to happen is if this guy puts $300 in this account that gets him 5% a year for 3 years, then after those 3 years, his $300 earns him $45. So he would then have a total of 345 because his initial 300 plus the 45 that he earned. Okay, so that's what you get if you're getting 5% using simple interest. The real world, though, what you want if you're investing is something that's a step up from that. So simple interest normally isn't enough for something real. So what we'll have in the real world is something called compound interest. The way compound interest works is the interest that you make is then added to your principal amount, and then it's plugged back into whatever this thing is that's earning you interest and used for new calculation. So if this was being used instead of simple interest for compound interest, what you would do is you would calculate how much this dude earns in the first year, add it to the 300, and then redo the formula with however much he made in that first year added to his 300. Right? And then you'd redo it each year. So this is this I'm giving the most basic way to go about this, because if you were really going to go into some deep stuff on this, there's tools that you could use to calculate it and stuff. So I'm just kind of dipping your toe in the water here. But so what happens with compound interest is it's compounded is the idea. So it's whatever you earn is reinvested, and then you have even more as your principal. And then the second time around, you earn even more, add that to what you're investing. And it ends up, that's how you find investments that double your money, is compound interest. And so if we're going to do something where the interest is compounded annually, then every year we figure out how much is earned and we add it to the principal amount. And the power of compound interest is really the way that people use investments to build wealth. I'm gonna talk about somebody named Dave Ramsey, who's he's like a financial guru. I'm not gonna push him too hard by any means, but it's the suggested reading for the course. And when we get into budget, I will bring up I'll quote some of his stuff. But for me, I've always been a math guy, but early on in my adult life, saving to me was this unspiritual thing that was just for people that are worried and that have too much money they don't know what to do with. For me, what made me realize like the practicality and the importance of saving is when I understood compound interest. It made me realize that that's how you can take a little bit and turn it into a lot down the road. And so anyways, I'll get more into that when we get to budgeting, but let me show you the math for compound interest. It would look like this. Let's take the same thing. Jim invests 3% at 5% for 3 years. And it's compounded annually. But let's figure out how you calculate the compound interest. So what you'll do is you'll use simple interest for the first time period and then use it each time for the compound. So look at the formula. I equals PRT. So so you're going to say is his principal is 300. His rate is 0.05. But instead of doing just running all 3 years in the single formula, let's just figure out how much he earns in the first year. And if you punch that in, he earns $15. So his 300 earned him 15. So think about it like this. He put in 300, that didn't disappear. He earned 15. How much does he have now after the first year? Well, he has a total of 300 plus 15 because we're going to use that as well, which is 315. So now his investment for year 2. So what you'll do is you'll say I with a little 2 for year 2. In year 2, what he's going to earn is not 0.5 at 1 year off of the initial 300. No, because he already made $15. So his total is 300 plus 15, which is 315. And 315 is earning 5% for 1 year. So you'll then plug this in and figure out how much his interest is in year 2. And in year 2, he earns $15.75. So notice that in the first year, he made 15. And in the second year, he made $15.75. Why is he making more in the second year? Well, because a little bit more was put in there. And now he has the 315 that he initially used here, but you're going to add what he earned to that. And so the 315 adds a 15.75. The rate is still 0.05. You do it for 1 year, and now this is what he earns. So now I'm going to add these together, 315 plus 15.75, which is 330.75, and add what he earned to that. And his final amount will be 347.29. Compare that to if we did simple interest, was just 345. So you'll notice the 347 in 3 years, he earned a little bit more. Compound interest and simple interest, compound will always be more. And the more time that goes by, the more you'll see the power of compound interest. So that's the idea with compound, is you do the simple interest calculation, but you stop every single year and figure out how much you made and put it back in. There are much more complicated formulas, and there's a lot to compound interest, but this is just the simplest breakdown I want you to look at for now. All right, so then the next thing is something called ACMR, which stands for an Accumulative Church Ministry Report. And we're not gonna go too far on these, but I'm just gonna use, while we're talking about percents, I'm gonna bring this up. So when analyzing and reporting, that's a huge spot where percentages are going to be used to give us an idea of if we're increasing or decreasing. Because think about it, if I say the church lost 20 people last year, is that a big deal or is that a small deal? Well, I don't know. Because if it's a church of 2,000 people that lost 20, it's not a huge deal, right? Like 2,000 member church lost 20. I mean, that could be, who knows? That's not some sign that there's some crazy problem at the church. But what if it's a church of 50 people that lost 20? That's a pretty big deal. We need to rethink if we're renting a building, I don't know if we can afford it, right? That matters. So instead of saying the number, you give a percent. If a church lost 20% of its people, that's kind of big. If it lost 20%, that means if it's a 100-member church, it went down to 80, right? So we want to use percentages when we're reporting things like this. So the formula for a percent of change, the idea is this. This formula looks really complicated, but I promise you it's not as bad as it looks. If you want to say the percent of change in a church, what you do is you figure out your final amount. And I'm going to write this formula here and go to it in a second. So percent change equals final amount minus the original amount. Final minus original divided by original. So the idea is you find the difference. How much did things change last year? What were they at the start of the year? And you make a percent by taking how much they changed and divide by what they started as. This looks really complicated, but I really think it'll simple up when I show you an example. So let's do this. Figure out, so the percent of change is going to tell us the amount of change compared to the original amount. So let's use this. Let's figure out the attendance in a church. It was 80 in week 1. So week 1, it was 80. Week 2, it was 120. Okay. So let me stop sharing. So our congregation had 80 and now it has 120. What's our percent of growth? What's our percent of change here? So what's our final amount? Our final amount is 120. So to figure this out, we're going to go 120 final amount. What do I do next? Subtract the original amount. How many people did I start with? 80. Okay. And then divide that by however much I started with, 80. 120 minus 80 is 40. And then 40 over 80. Let's turn this into a percent. And so that's going to come out to 40 over 80 is going to be 0.5. And then to turn a decimal into a percent, I'm just going to move the decimal place over 1, 2. So it's 50 and put a percent on it. So my church has grown by 50%. If it goes from 80 up to 120, that's a growth of 50%. Okay, so this percent change is how you would do an ACMR, which is a fancy way of just saying the way you would report statistics at a church. Okay. So all these things are things that we're going to want to use for these problems that I'm going to have you do. Honestly, I would say this, like if you didn't write down these formulas, you might want to go back. I mean, I don't know, I'll do this. So you can pause here if you need to, but here's your formula for percent change. I would just take a piece of paper on the side, write percent change, and boom, then put this formula. Pause it if you need it so you can look at it. I'm gonna move through this. If you need to do interest, here's your formula for interest, I equals PRT. And then compound interest, there's a whole nother complicated formula you could use that I don't want to get into. So for our compound interest problems, I'm going to let you break it down as doing the simple interest formula, but for every single year. Obviously, it's annoying if we're talking about a lot of details, but and then with these things, you might just want to scan back and re-watch these if you need to. But this is kind of an example of everything. So now what I want you to do is I'm going to let you work on this a bit. Let's go to page 46 through 49 in our text for this class. And you're going to start with number 1 on page 46. And you're just going to work through these problems. And you'll end up at number 24 on page 49. So 24 problems. The answers are on page 50. And so if you're able to go through this, work on them, and you double check and you're getting all right, that's great. But what I will do is, so as soon as I'm done talking here, you can pause, work on all of these, and then I'm gonna go through all 24. So if there's any ones where you did it, you got your answer wrong, you looked at his answers, you're like, well, what happened there? You can scroll through until you see me work that problem and get the help you need there. Let me do this. I didn't do this last time we did this, but let me close in prayer because this could be it for some of you that don't need to watch me do these problems. And then once I'm done praying, press pause, work on all this stuff, and then play to see how I do it if you need to. So let's pray. Lord, I thank you for this class. I thank you for each and every single one of these students, Lord. I believe, God, that what we're doing here, that you will honor this beyond even what we can see, God. I just think that the the work that the staff at Legacy puts in to try to offer this stuff, the work that the students put in to learn these things. God, I believe that you will honor that. I believe that you will honor everyone's time. I believe you will honor everyone's discipline and diligence, and that you will use these things even in ways we can't imagine, God. So we just believe that. We have faith that you're going to use this time, and God, we do this for you, and we give you this time, Lord. And we thank you for this. I pray that you just open everyone's mind, give them a level of wisdom and understanding beyond what their elementary and middle school and high school teachers thought they were capable of, and use us in Jesus' name. Amen. All right, press pause, run through these questions, and then you can press play and watch while I do it. All right, so let's go ahead and go through it. Let me erase this. All right. It might chop in a second. I'm gonna pause my recording and take care, get a couple things together, and then I'll get started. So if you randomly see me move, it's because I paused and pressed play. All right, I'm back. Got myself some water, help me get through this without losing my voice. But let's do these problems here. So gonna take it from the top. I'm assuming you have the PDF or the book in front with you. So I'm not gonna write all the questions. I'm just gonna go through them and show how I calculate the answers. So 2/3 convert to a percent. So 2/3. I'm gonna just pull the calculator. I'm gonna have this handy. So 2 divided by 3 is gonna be 0.66666. We round this over 1, 2, and we were gonna round everything at the 10th. So 66.7, put a percent on it. Each thing I do, I'm gonna double check, make sure I'm getting the same answers. Oh, okay, so he actually, in his answer, he's rounding to the nearest ones place, not the 10th. Actually, it's different for different ones. So I'll be consistent in rounding to the first decimal place to the 10th. Seems like he's alternating between rounding on the ones and on the 10th. I'll just say, just be consistent and pick one thing and roll with it every time. If you round to the ones place, that's fine. Next up, 7/8. And so I'm just gonna do the calculator. 7 divided by 8, 87.5, or 87. I'm already jumping ahead in my head. 0.875, move this over 1, 2, 87.5, throw a percent on there. 0.23 to a percent. 0.23. I'm literally just gonna move over 1, 2, 2, 3, put a percent sign on it. Convert 95% to a fraction. So 95%, you know what I should probably do? I'm a math teacher, I know better than this. I need to keep things organized enough where you can follow along. So number 4. All right, so 95%, and we're gonna make it into a fraction. 95 over 100. We can't leave it like that, we need to reduce. So both of these things can be reduced by 5. 95 divided by 5 gives me 19. 100 divided by 5 gives me 20. So the fraction version of that is 19 over 20. Okay. Number 5. 45%. Let's make this into a fraction. So that's 45 over 100. Divide by 5. Divide by 5. That'll be 20 again. And 45 divided by 5 is 9. So 9 out of 20. 37% to a decimal. 37%, get rid of the percent. The decimal starts on the right, move it over 1, 2, 0.37. 22% to a decimal. 22%, make it 22, take your decimal, move it over 1, 2, 0.22. Okay, these are just property taxes are due on what? You need to pay property taxes for vehicles and for real estate. And what taxes are exempt for 501c3s? That's sales and property tax. Definitely not income tax. If you are purchasing for a church dinner, number 10. Let's see. Let's go ahead and let me erase what we got here, and I'll start with number 10. I'll probably take a little more room for these word problems just to kind of map everything out that we're dealing with. All right. So number 10, you are purchasing for a church dinner. The cost of all the items on your grocery list is 189.45. And if you use the church tax letter, how much sales tax would you be saving if the tax rate is 7.2%? So just let's figure out the tax on that. So let's take 7.2 and turn it into a decimal. So the decimal starts here. So move over 1, 2. So 0.072. And I'm just going to take 189.45 multiply by 0.072. And let's just do this on the calculator. 189.45 times 0.072. And we get 13.64. That would be the amount of money that's spent on taxes. And that would be what the church would save if we use our tax exemption stuff. So a drum set costs $599.99. The sales tax is 7.38. What is the actual cost? So $599.99. Sales tax is 7.38%. So let's make that into a decimal, which move over 1, 2. So 0.0738. And then so I'll just multiply this by that decimal, 0.0738. And so 599.99 times 0.0738. We get 44 point. We're going to say I'm getting 279, but we're talking about money. We never care about fractions of a percent. So I'm going to round 2 decimal places to the hundredths place. So I'm getting your cents. So 44.279 means I round up to 28. So this is the cost of the tax. So to find the actual cost, we'll do 599.99 plus 44.28. So 599.99 plus 44.28 gives me 644.27. So that gives me, that's factoring in my actual cost, which is going to be how much the item is plus what tax I'm paying. Number 12. You're purchasing power speakers for the outreach team. The cost of the speakers that you want are $349 each, and you plan on buying 2. Let's make room for number 12. So $349, we're buying 2. The salesperson notes that the store will be having a store-wide sale with 10% off all electronics. How much could you save if you wait till the end of the month? So we're just figuring out how much we're going to save. So it's 2 of them. So 349 plus 349. So 349 plus 349. Oops, 349 plus 3. I keep typing the decimal, 349. So it's going to be 698 is what we're spending. And we need to figure out how much money we're going to save if we take 698 and we get 10% off. So 10%, take the decimal move over twice, is 0.1. So we're going to save 10%, which is decimal 0.1. So let's do 698 times 0.1. And when you do 698 times 0.1, 698 times 0.1, which is basically just taking this and moving the decimal place over, we get $69.8 is how much we're going to save. So the savings will be $69.80. Number 13. Let's erase this again. Okay, 13. You're buying chairs for the fellowship center. You presently have 10 tables that need 8 chairs. Chairs cost $249 each. If you buy 100 or more, you'll get a 30% discount. How many chairs should you buy and what will be your cost? So we have 10 tables. They need 8 chairs each. They cost $24.99 each. So 10 tables, 8 chairs each. So we need 80 chairs. We need 80 chairs. So if we go 80 chairs and we buy them individually, they'll cost $24.99 a piece. So 80 times $24.99. 80 times $24.99 will cost us $1,999.20. So you think you want a pastor, you get to spend $2,000 on chairs. So cut the cost. That would be if we buy each individually. Or my other option, so this would be buying 80 chairs, cost me $19.99.20. Let's see if that's the way to go, or if what I do is buy 100 chairs times $24.99, which is going to be $2,499. But the thing about that is that I get a 30% discount, which 30% is like 0.30, right? So 30%, I'm gonna convert that into a decimal, move over 1, 2, so 0.30. So what's gonna happen with this is we will get a 0.30, a discount of 30%. So 2,499 times 0.3, we will save $749.70. So what's going to happen here, we'll have 2,499 minus 749.70. So 2,499 minus 749.70. And so it will actually cost us 1,749.3. So 100 will cost us $1,749.30. So what should we do? We should actually buy 100. If we want 80, we're better off buying 100 chairs, having 20 extra, because the total cost will be 1,749.3. Double check my answer there. 80, yep, he agrees. 100 will cost 1,749. So buy 100 and save about 250. So his answer agrees with what I came up with there. All right, number 14. 45% of your class needs help buying the book for the class. You have 19 students. How many need assistance to buy the book? So let's just figure out what is 45% of 19. So 45%, which I'm gonna go decimal, 45% of 19. That's just 1, 2, so 0.45. So I'm gonna do 19 times 0.45. So 19 times 0.45 is 855. Make sure I'm doing this right. 8, yeah, so 45% of 19. So we have 8.55. You can't have 0.55 people. And so if you have, the idea is, think about it like this. It's like, if it's get money, raise the money or fundraise to assist 8.55 people. So think about it in terms of what's 8.55 people. That basically is saying 8, maybe more, right? It's something a little above 8. So if your number tells you 8.55 and you know that there's no such thing as half a person, do whatever it takes to help 9 people, since you want to assume. So the idea is this is how many people need assistance. The numbers are telling me 45% is telling me something above 8. So we're going to say 9. So with this, you'd say 9 people. So just expect that when you're running your numbers and you're talking about like how many, how many specific items do I need to buy? How many gallons do I need to buy? How many whatever is pizzas do I need to buy? How many people do I have? You'll get decimals. So round it so that you always will be prepared for extras. So if you're buying something for 8 people, but your numbers say there's going to be 8.5 people, that means you need to buy for 9 people. So we'll say 9 for that one. Number 15. 34% of the congregation has been baptized. If you have 296 in your congregation, how many have been baptized and how many have not been baptized? So we have, 15. We have 34% of the congregation has been baptized. So 34%, so 0.34 have been baptized. And we have a total of 296. So our calculation is 0.34 times 296. So we have 100.64. There's no such thing as 0.64 people. So we're going to say 101 have been baptized. And so we'll be doing 296 minus 101, which gives us 195 have not. So 101 have been baptized, 105 have not. Let me make sure he's saying the same thing. Yeah, 101 have been baptized. And I think he made a mistake in his answer because he said his answer, I'm looking at the answer column 15, he says 101 and 295. If there's 296 total and 101 have not been baptized, there's no way it's 295 for have not. So just go with this. 101 have and 195 have not. All right, so number 16, your church has decided to use fundamental budgeting. You've designated, we'll get into that later, what that means. You've designated 10% for missions, 35% for salaries, 20% for building, and 35% for programming. Your anticipated giving for the next year is $70,000 for your small congregation. How much will each fundamental receive if you have $70,000 coming in? So number 16, we have $70K, and the breakdown is going to be missions is 10%. So we're going to do 70K times 0.10. Right. I hope you're okay with me jumping to that instead of 10%, I just already know 10, move over 1 to 0.10. 10% for mission. Salary is 70K times 0.35. 20% for building is going to be 70K times 0.20. And what am I missing? Programming is 70K times 0.35. So 70 times 0.10 gives me $7,000 for missions. 70 times 0.35 gives me 24,500. And I don't need to redo this one. So this will also be 24,500. And then 70,000 times 0.20 gives me 14,000 for the building fund. Okay, we'll get more into that type of budgeting with ministry in the coming weeks. So let me erase, make room for number 17. Number 17. Church is really growing. Church experts say to either go to two services or build when you reach 80% in your sanctuary. If your sanctuary will seat 80, at what attendance should you consider building? So we need to consider building at 80% of our 80% of our capacity, which is 80. So for number 17, our question is what would be 80% of 80? So that means we're doing 0.80 times 80. So 0.80 times 80. So that means once we hit 64 people, we need to either build or go to two services. Okay, hold on. Is this thing blurry for you as well? I hope that on my screen, what I'm seeing is really blurry. I hope that the recording is better. I don't think that, I think the recording will be just as bad as what I'm seeing right now, though. Let's see what I can do about this. Let me try to scoot this thing. So anyways, number 17, I have 0.80 times 80, and the answer comes out to 64. So 64 is our answer there. But I need to give this a second and figure out how to keep this from being so blurry. Technical difficulties. I'm gonna pause and see what I can figure out before I press play again. Yeah, I think I got it figured out. Let's hope that this sticks. Looks clear on my end, so I hope the recording is clear for you. But there we go, number 17. All right, let's move on. Number 18. You reached 80% in your sanctuary. To build, you will need a construction loan of $350,000 for 1 year of the construction. The bank will give you 6% on the construction loan. How much interest will that be for that year? So interest equals principal times rate, P, principal times time. And we're trying to figure out our interest. Notice the way this problem is, you've reached 80% in your sanctuary. Don't get thrown off by that. That's why we're building. And what we're going to need to do is borrow 350,000. That's our principal. Our rate is 6%. So first thing we need to do is turn 6% into a decimal, which means take the decimal, move it over 1, 2. So 0.06 is our decimal. So it'll be principal is 350K, 0.06 is the rate, and the time will be 1 year. And then we just plug all of that into the calculator. So it's going to be 350,000 times 0.06 times 1. So our interest will be 21,000 for that first year. So the idea is you would be making to borrow that money. And again, no real mortgage works this way, but you owe them 21,000 within that first year, which is your charge of borrowing that money. That's assuming you're not paying any of it back in that first year, but you now owe them the initial money plus 21,000 for having borrowed it. That's the power of being the lender, and that's the disadvantage that you're into when you're borrowing too much money. So anyways, number 19. After building is complete, your church gets a balloon mortgage that comes due annually. The loan will compound quarterly 4 times during the first year. The interest rate will be 3%. The amount of mortgage is 310,000. If nothing is paid the entire year until the mortgage comes due, what will be owed? Okay, so with this one, what we're going to do, building is complete. It's due annually. The loan will compound quarterly. So the loan will compound 4 times during the first year. The interest rate will be 3%. So I'm assuming that if it's compound 4 times, then the interest rate, this is kind of like the way the question's worded makes it kind of confusing. And again, we're not trying to get into high level compound interest. But the question is worded in a way that I think makes it kind of confusing here, because the interest rate being 3%, but it's compounded 4 times in the year. I'm assuming what he meant when he put this question is that 3% is each quarter. So it's compounded 4 times. And so I'm assuming he wants us to do this. Assume that we're going with 310,000. And our rate is 3%, which would be 0.03. And our term, we're assuming that it's in 1 quarter. And so then after the first quarter, we'll do 310,000 times 0.03. And so that's going to come out to 9,300. Let me double check something here. Okay, so no, he's actually not doing it that way. He is, okay. Okay, hold on. I'm gonna pause and I'm gonna double check something. I'm gonna run some calculations to figure out what it is he's doing, so then that way I'm not wasting your time as if you're watching this to figure out what to do. Okay, so for what it wants to do for 19 here, I expect most of you will end up wanting to watch the video and at least scan to this point, because it's especially if you do the reading on top of watching the videos, which you are supposed to do. Up to this point, my videos have covered everything you needed in the reading. So you'd be just fine watching my videos. And if you had skipped the reading, you're not supposed to, but you'd be fine. For this lesson, I think that the reading would be kind of helpful, because especially in this case, I just went through a basic example in how compound interest works, but there's a lot more on compound interest on page 44 and 45. Well, actually, I'm sorry, on page 42 and 43, and then really 42, 43, 44, and then it stops talking about compound interest on page 45. It's probably worth reading to see some details, to see some more examples. I think my little example of compound interest can kind of get you started, but you probably be a bit confused hitting this question if all you saw was my example. So I would suggest to go back and do the reading if you hadn't, if you struggled on these questions, but I will still break down how to do this and why it works this way. But this is going a bit more advanced than the simple example I gave in the video. So the reading will supplement and help you on this, but I'll explain it. So the way he's wanting you to do this is we're assuming that 3% is not the rate that you're being charged per quarter. So I guess let me break it down. So it's like this. I equals, hold on. I got to pause again and go get a different marker. So, all right, we'll go over the red marker. That's what I found. It's a good thing I found that I could pause in the middle of recording, do what I need to do, come back and press play. Otherwise, today y'all would have had all this downtime where I'm running around getting water and stuff. But anyways, so I equals PRT. Now, what this the idea for this question, the reason why I had to double check something to figure out how it's setting it up, it could either, and it's saying what happens is that your loan will compound quarterly. So it's going to compound quarterly or 4 times within that year. So where I was unsure what they were saying is that we take our interest rate and it's going to be the principal, which is 310,000. Okay. And then our rate is 3%, which is 0.03. And the time I'm going to say is 1. And I don't know if what we're saying is that this rate, since this is going to happen 4 times in the year, I wasn't sure if they were telling me that that interest rate is charged to me each quarter, and that happens 4 times, and then we get to our total. That would have been one calculation, which is what I was starting to do. I was using that assumption when I was starting, and it looked like my number was going to go past his answer. What he's saying is that your rate for the whole year is 3%, but they're going to stop and charge you after the first quarter, figure out how much interest you've built up, and then they'll compound it, meaning then they'll add that to your total. So this right here would find us the whole year, but we're going per quarter or 4 times. So what we need to do is, if I do that whole number, it's going to give me my interest over an entire year. What do I get at a quarter of a year or at a fourth of a year? So it's 310,000 is my principal. My rate is 3%. So 0.03 is what I plug in for my rate. It's going to happen over the course of 1 year, but we're stopping at a quarter of that year. So let's run this in and see what we get. And we will end up with 310,000 times 0.03. I pressed plus. Let me reset my calculator. 310,000 times 0.03. And then that's going to be times a fourth. And so what we're going to build up is we're going to build up interest. And I'll put this is in the first quarter. So in the first quarter, we're going to build up interest of, we punch in all these and we get 2,325. So $2,035 will be our interest in the first quarter. Okay, now they compound it, which means you don't get to pay that off. You're not dealing with that. But they say, you now owe us this. How much did you owe them to start with? Well, you started with 310,000. So now what they're going to do is they're going to go take that 2,325 and they're going to add it to what you owed them at the beginning. And so we'll do the 2,325 plus, let's set this book down, plus 310,000. And so now what you owe them is 312,325. So you see what I'm saying? So what we're doing is we're saying we're going to owe them this amount after the year, but at a quarter of the year, they're going to stop. So, and figure out how much I owe them, how much interest I owe. They're then going to add that to my rate. And now we're going to go back into the formula. So quarter 2, we're going to go back into the formula. And we're going to do interest is, but now the amount I owe them has gone up. It's not 310,000. It's 312,325. And my rate is still 0.03. And we're still doing it for a year. But they're not going to go and do the rest of the year. They're only keeping it at that for a quarter of a year. And then they're going to run the numbers and figure out how much interest is built up. So now I'm going to punch in my calculator 325 times 0.03 times 1, and then times 1/4, or you could just do divide by 4 at that point. And now my interest is going to be, on the second quarter, is going to be 2,342.44. I might be off from his answer by a little bit because I'm going to round at the second decimal place every time because we're talking numbers. So that's how many cents I'm at. Okay. So now that's my interest. So I'm going to take how much I owed at the beginning of this quarter and how much interest I've built up and do 2,342.44. And then we're going to add 312.325. Okay, so how much interest I built up versus what I owed them at the start of the quarter, and we'll total that. So my interest, so I'm going to do 2,342.44 42.44 plus 312,325, and we get 314,667.44. Okay, that's how much at the end of the second quarter I owe. So now we begin the third quarter. My interest rate is going to be 314,667.44. That's not, I said interest rate. My principal is this. My rate is 3. We're still doing it for a year, but we're stopping at a quarter of the year. Punch all that in. So 314,667.44 times 0.03 times 1, and then divide by 4. And so our interest we build up is 2,360.0058. So I'll round it to 0.01, so a penny. That's our interest. And so this quarter, we take our interest, 2,360.01. We add it to what we owed at the beginning of the quarter, 314,667.44. And let's see what we get. So 2,360.01 plus 314,667.44. And so now what we owe is 317,027 and 45 cents. So we're at $317. So 3 quarters into the year, so every quarter we're stopping, and just make sure you get it. So we started off, we owed them 310,000. They're going to charge us at 3% a year, but we stop at a quarter of a year and we built up this much interest. So after a quarter of a year, instead of owing them 310, we owe them 312, 325. Plug that in. That's our new amount. Now that's what's earning interest for them. And now the interest in the second quarter is 2,342. Look at the interest after one quarter. Look at the interest after the second quarter, right? That's why if you owe something, especially if it's compounding, you need to be keeping up with those payments and bringing your interest or your principal down. Otherwise, if you have something where the interest gets compounded, then if the balance is going up and up and up, you can see how it's going to get out of control. After the next quarter, our interest rate is here. Or I mean, our interest built is here. So we add that, and this is how much we owe them. Plug that in, and the interest earned in quarter 3 for them, or the interest we owe, is that. Add it to the amount at quarter 3, and now suddenly we've just blinked, and after 3 quarters of a year, we owe them $317,000. So for the fourth quarter, to finish this problem up, we have I equals 317,027.45, still at 3% interest rate, and we're still doing it for a quarter. And so the interest built up here, 317,027.45 times 0.03, and then we take a quarter of that, and so we're at, our interest will be 2,377.71. That's our final interest, and at that quarter we have to add that to 317,027.45. So that was our interest at the quarter, and our final amount we owe them at the end of the year, if they're compounding each quarter, is 2,377.71 plus 317,027.45, and we end up at $319,205. I think I'm 100 or 200 off from the answer he puts in the back of the book. I think in his book at the end of the chapter he puts 319,405. So I'm off by a little bit here. Well, hold on, I might be because I did a typo. Let me double check this. 2,377. Yeah, I think I just mistyped on this. So let's there 2,377.71 plus 317 027.45. Yeah, okay. That was a typo. I should get 319,405, which is what he got. If I'm gonna be exact, 0.16, but he seemed to round the cents away. So this is how you'll calculate compound interest if you're stopping within a fraction of a year, a quarter of a year. Now, the way it's calculated in the real world is every day. So it's stopped at every 1 out of 365, and they say, how much do you owe at the end of the day today? The next day, how much do you owe at the end of the day today? The next day. And so like in a mortgage, they do that each day and it builds up over a month. But then at the end of the month, you pay some money. A lot of it goes towards that interest that's built up, and whatever's left to deal with the interest that built up that month, the leftover go towards your principal to bring your principal down. That's why if you've just bought a house and you make extra payments early, it really helps, because the extra payments don't get eaten up towards this interest you're building up. It instantly lowers that principal. So anyways, this is a complicated problem. I'm not going to put a problem like this on this degree of complication. Is not even a way to put it. This degree of difficulty, this complicated, won't be on a quiz or on the final exam. I would like you to understand this, though, because a big thing this does for you, understanding compound interest, is going to light a fire under your tail if you're in too much debt, which is a good thing for you to actually understand why that debt is killing you. There's a reason why there's a proverb where the Bible says that if you are in a situation where basically it says if you're in a situation where you owe money, if it calls you a slave, it says the borrower is servant to the lender, and it basically puts it where if you're in a bad if you're stuck in a bad loan situation, is the way it puts it, one way of saying it, then you need to run like you're a deer running that's being hunted. So anyways, number 20. After the building is complete, your church gets a balloon mortgage that comes due annually. The loan will be compounded biannually, so it's compounded 2 times during the first year. So we're just gonna compound it 2 times, so cut it in half. And the interest rate will be 3%. The amount of the mortgage is $310,000, but before the end of the first 6 months, you're gonna pay $32,000 before it compounds. In the second 6 months, you pay $40,000 before it compounds. What will the balance be after the end of the year? Okay, so let's see. So what we're gonna have is we're gonna take 310,000, and before anything happens, before the interest rate, so let's see, let me make sure I'm understanding all this. Balloon mortgage, it's due annually. The loan compounds during the first year, and before it gets compounded, we're going to take our principal and we're going to pay 32,000 of it before it compounds, before the calculation goes into place. So we're going to take 310,000 and we're going to pay off 32,000 of it. If there was a loan structured this way, where at a certain point in time they do their compound, they compound it, and the certain point in time was 6 months in, it would be crucial if you raise 32,000 to pay it before the loan compounds instead of waiting till after. It'd be crucial. But anyways, here's what we got. So we're gonna go 310,000, and we get 32,000 of that paid off. So now our amount we owe them goes down to 278,000. And I'm gonna do, remember, I equals PRT. So I'm going to do our interest equals our principal, is the rate 3%. The rate will be 3%, which is 0.03. It's going to happen for 1 year, but we're stopping at a half of the year. It's happening 2 times in the year. So halfway through the year, we're going to stop and calculate what's happening. So let's go ahead and do the numbers here. So 278,000 times 0.03 divided by 2, or times 1/2. And so the interest built up here is going to be 4,170. So $4,170 is the interest that we'll pay. For the sake of time, I'm not going to calculate it if we didn't make that payment, but let me tell you, this would be worse if we didn't make that payment first. So that's the interest. So our $278,000 that we owed them after the payment, because at a half-year point, they calculate their interest. That's how much interest is going to get tacked on. So we're going to be at 278 plus 4170. So we'll be at 282,170. That'll be our amount. And this is all within that first half of a year. That's what we're at now. Okay, now following what the problem says. Before the loan compounds, in the second 6 months, we take this, and in the second 6 months, we're able to take 282,170, and we're able to pay off 40,000 before things get calculated. 282,170, 282,170, and we remove 40,000 from that. And now our loan is at 242,170. That's our loan now. Our rate is 0.03. It's happening for a year, but we're going to stop at a half of a year. So we're going to do 242,170. Oh, hold on, I'm making mistakes on my little calculator here. 242,170 times 0.03, and then that's times a half. So we end up with our interest is 3,632.55, and the amount we owed was 242,170. So add that to the amount we owed. So plus 242,170. And so we end up with, what will the balance at the end of the year be? It'll be 245,802.55. And that should be what he gets. This is going to be bad if it's not what he has in the back of the book. And yeah, he breaks it down. Yep, he gets the exact same thing. So that's the way he structured the problem. He was expecting you to do it this way. Again, doing compound interest like this, I won't expect you to do something quite this complicated. The problem that I would give on a quiz or exam that uses compound interest will be the level of difficulty of the simpler example I gave earlier in the lecture. This is good practice. This is closer to the real world. The reason why I'm not going to expect you to be able to do all this is because anytime you're dealing with this, there's likely to be an easier way to calculate it. You'll be with an accountant, or you'll have a mortgage calculator. If it's a mortgage, they give you this amortization schedule, which shows you your principal versus your interest and how it changes. But I do want to go through this process, have you have tried it, see me do it. So this helps you to understand how these compound loans are calculated a bit better. If you want to get better at these, you can take it a step further. Honestly, just teach yourself stuff. Look it up on YouTube, how to calculate compound interest. You can get really good at this stuff. But this is as far as I want to go for the sake of this class. All right, let's look at these last four ACMR questions, number 21, 22, 23, and 24. And we'll be able to wrap this up. So 4 more questions. All right, so the ACMR numbers are in. Last year, your attendance was 57. So your original 21, remember, we're going to do percent change is final minus original divided by original. So our original number was 57. Our final, your year average was 122. So the final number was 122. So we're going to do 122 minus 57 over 57. So the change, 122 minus 57 gives me 65. And then 65 divided by 57 gives me 1.14. And so I'll check some here. And so what we get is that, so we move this over 2 places and we get a 114% increase. So you just do whatever your original was, final minus original to get your change, divide that by the original, and then remember to move it twice to get it from decimal to a percent. Okay, number 22. Last year the church had 74. 74. This year it has, so original, this year it's at 42. That's our final. So we'll do 42 minus 74 over our original was 74. So this is a decrease. So we're gonna have a negative percent. So we do 42 minus 74. So we have negative 32 over 74, which will give us divided by 74. 2 divided by 74. So we're going to get negative 0.43. I'm just rounding 2 decimal places. So that is negative, move this over 1, 2. So we have grown by negative 43%. We lost 43% of our congregation. That would not be ideal. Number 23. Number 23, last year we had our original is 357. Our final is 556. So we have 556 minus 357, divide by 357. So 556 minus 357, divide by 357, and we get 55.7. So I'll say 0.56. I'm rounding to the second decimal place, move it over 1, 2, so 56%. So in this case, our adherence grew by 56%. Mardi Gras, last year students prayed with, so let me just do this right here. Our original, so what we're comparing to last year was 8,357. That wouldn't be bad to pray with 8,357 people. And then this year, our final was 9,346. So let's get our percent change is going to be final minus original. You can maybe make sure you can see what I have going on here. Yeah, okay. And then that's divided by whatever the original numbers were. And so that's going to get us 9,346 minus 8,357, divide by 8,357, and we get 11,118. So I'll round it to 12, move over, so 12%. And yeah, that's what we get. All right, so that's ACMR right there, and then we have the compound interest. And then the next slide here, let's go back to sharing the screen. The next slide here is some review questions. If you can handle these questions, you pretty much know you get what you needed to out of here. Just understand the difference between simple and compound interest. So you could pause here, make sure you know how to do those. If so, you're good. You should be ready for the quiz and the exam at the end of the year, end of the term. If not, if you look at these, you're not sure what to do with these, go back and rewatch some certain sections. But that's it. That's the end of this week. I hope that this stuff made sense. And as always, email me if you have any issues.